Thanks, everyone. Welcome back after the lunch. I see some people are still joining the room. So, this pitch session is a bit different from what has happened in these days. In this session, we aim to bring together different EU projects, European projects, to, well, hopefully stem some thinking, some ideas, and look at what is happening and what are the common challenges and potential for development that they encounter. So, just to give a little bit of a background to this session, we have projects which come from the IPCEI-CIS, as well as the wider EU Cloud Edge IoT umbrella. So, the idea here is that well, I personally bothered all the project representatives in the last weeks, so that they come here with presentations with 4 common topics, so that we can, think together of what is happening, what it means, and maybe if we have a little bit of time, also have a little bit of a discussion. So we will have a brief overview of each of the projects, then we will know something about the key exploitable results, so the more market-oriented aspects. Then, and I think this is going to be quite interesting, we will have one slide in each of the presentations about lessons learned. So things which went well during the project and things which were more challenging. And last but not least, and also this point could be quite interesting, I think, is on the way forward. So after the end of the project, what is going to happen? So, as the time is tight for the 9 presentations that we're going to have today, I will introduce quickly the speakers and then leave the stage to all of them. First, we will have Kaya Swat represented a project of Phoenix RTOS from Phoenix Systems. Then we will have EMPYREAN represented by Aristotelis Kretsis from the National Technical University of Athens. Then Selma Azayes from CAA List representing the project COGNIFOG. Philippe Massonnet will follow on SovereignEdge.COGNIT and he is from CITIC. DSIS will be represented by Felix Stein along with Mira Kaidin. I think Felix will present on stage. Then we will have SEDIMARK represented by Tarek El Saleh from the University of Surrey. For the project intent, we have WeSong from Sintef Digital. TaRDIS represented by Carla Ferreira from the Nova University of Lisbon. And last but not least, of course, Vretos Moulos for P2 Code from the ARIS group. So, with no further ado, I would like to give the floor to Kaya. And you can use both this microphone or those microphones. And here is the clicker for you. Thank you so much. Thanks.
Thank you, Francesco. So, hello, everybody. My name is Kaya Swat. I represent Phoenix Systems, and I want to tell you something about our project that we are developing within IPCEI-CIS, which is Phoenix RTOS, the foundation for the distributed multi-provided cloud edge IoT continuum. Very long title of the project, right? So first, who are we? We are the company that is developing an operating system for IoT devices. And we actually are developing this system as an open source. Why and what is our goal? We want to provide an open source European technology. We want the sovereignty, we want the openness. We started from energy sector. The system is being developed for 20 years now. In energy sector, we have a lot of implementation in electricity meters, gas meter, data concentrator units. There's like almost 2 million devices now that are using our operating system, and also the software that works on top of this system. Why we joined ORA and IPCEI-CIS? Because we wanted to go into different sectors, different than energy. We want to take all the regulations that are in those sectors and the requirement, put it into our system to see how this impact architecture, to at the end have the system that can answer most of the requirements that you can have for IoT devices. So we want easy integration, we want the architecture that is relevant in most of the sectors, and the use cases that we are aiming at within IPCEI-CIS is space, aerospace, and industry. So, shortly, what are the key exploitation results? In aviation, we are building an autopilot for the drones. That's why you were hearing jokes yesterday that the drones are my thing, but no, these were not our drones. So currently, the autopilot itself is quite mature. It works on quadcopters, hexacopters, and on deltaplanes as well. What we do is that we developed a platform that enables execution of applications, in this case autopilot, but execution of AI as well, because we also build the electronics for the devices, and the electronics is based on the chips that support AI acceleration. Similarly, in space, we are aiming to have a prototype of a CubeSat that enables AI in space, because why would you want to always transfer the data back and forth? And in space, it's obviously very costly. So we want to pre-process the data using AI in space. So for now, we have the first implementation and porting of the operating system onto the platform that is RAD tolerant and RAD hard. We are collaborating closely with Geisler company, which is the company that is developing and manufacturing chips for space in Europe. At the end, we want to have this 6-unit AI-enabled observation satellite developed. Within the project, we will not be able to send it to the orbit, but we are looking for partners to do it after the IPCEI is finished. For industry, we are not that advanced yet because we have just finished the design of the port of the PCB. We've done the port of the system. We have prepared initial versions of the software for the device, but the device itself is being procured based on our project. The device is a sensor box. The idea is that you can attach a lot of different sensors to the device itself, put it in the factory to measure whatever you want, to put your applications on the sensor box, and to have the environment that allows you for execution of this application as it would on Linux, because we're having POSIX API over there. And when you have this flexibility and this availability, you can change the factories that are using the old machines and old technologies into factories of Industry 4.0 or even 5.0 in the future. And our main focus is, of course, the operating system itself. As you can see, it's available on GitHub. We have already ports for ARM v7, AMR, v8, IA32, for Spark. Spark is an architecture that is used in space, for RISC-V, because the current CubeSat platform will be actually based on RISC-V. So lessons learned. Generally, it's been amazing cooperating within IPCEI. We met 4 years ago during matchmaking. It's very nice to come back to these gatherings like we have here today, to see familiar faces, to see that the cooperations are alive. We learned that we want to do the innovation, but we have to keep in mind the business cases. So at the end, what we are doing has to be commercialized. What I learned personally is that the community of edge cloud IoT is getting much stronger. With each year that is passing, I see that the change is coming, and slowly we are seeing the change. We learn that we have to listen to each other, because my point of view not necessarily is your point of view, and you are bringing a lot to my expertise, but also to my development and my future products. And the way forward for us, for aviation, is the commercialization phase. The autopilot will be commercialized in at least 2 versions, the basic one for smaller targets and smaller relevancy missions. The bigger version will be, for example, used within IPCEI with cooperation with T-Systems to inspect the antennas and do predictive maintenance of logistics centers. For the space sector, after the project, as I said, we will be placing the satellite on the orbit. So we will be looking for partners for that. Maybe if you have ideas about the applications that could be run from space, that is something worth talking about, because we will have a platform that will have optics, cameras, AI capabilities, and direct connection to Earth. And in industry, we are looking for collaboration that will help us commercialize the sensor box. I've seen many projects today, and I will be reaching out for sure to reply, because maybe there is something that we can work on together. And in terms of system itself, the things that I would want from all of you guys is to form first the community of companies working on the open source, to share ideas how to do it, how to make business cases around it, so we can share it with the companies that don't do open source, so they are not afraid and they know how to do it. And also, one small point, we have implemented a WebAssembly port onto our RTOS. If somebody is doing the cloud layer of WebAssembly and wants to do something together, please call me. So thank you very much. Are there any questions?
Thank you very much. I think we have time for one question for Kaya. Okay, so make a note of the contacts, because I think there was really, really interesting things in this presentation. Alberto.
Very quick question. Thank you, Kaya. How are you guys in the serverless paradigm, in the way your devices interact with the continuum? Can you explain some more? Are you working on some stuff?
So Felipe will tell you guys more about the COGNIT project where we are actually developing together a serverless paradigm. For us, we have the energy use case over there, so the meter is actually executing function as a service. Our function is more or less AI decision algorithm that is executed to give the answer to the meter if something has to be changed in terms of managing your household energy consumption and production. We do have similar projects when we are doing hybrids of functionality for small devices. We have a functionality for data concentrator unit which needs a lot of resources normally, but we cut this functionality into 2, and part of the functionality, which is gateway for data, we are executing on the meter, and the other part is being executed in the cloud. So that is an example of the whole continuum being covered, because we have cluster that dynamically assigns resources to each meter. Whenever you need the additional resources, they are created. Does it answer your question, Alberto?
Fantastic. Whoa, that was loud. Fantastic. Kaya, thank you very much for your great presentation and also for joining us in this session, despite a very tight flight schedule. So please applause to Kaya. And
if you want to reach out, use the email or LinkedIn, and I'm running to the airport because my flight is pretty soon.
Thank you very much, Kaya, again. So, next up we have Aristotelis Kretsis from EMPYREAN. If you want to reach the stage, then for the next question, we take them all at the end so that we stick to the time, all right? The floor is yours. Okay. Thank you very much.
Good afternoon, everyone. I'm Aristotelis Kretsis. I work at SES, and we are part of the team of EMPYREAN project. Our project includes 10 partners, as you can see, from 7 different countries. And actually, we're a project that we just passed the second half of our duration, coming from a successful review. And also, we have successfully released the initial version of our EMPYREAN platform. EMPYREAN vision actually it's to enable a collaborative autonomous computing continuum across heterogeneous resources by connecting IoT, edge, and cloud systems in a trusted and intelligent way. To do this, we introduce and provide the mechanisms to build federations of collaborative resources. These federations, their aim is to enable IoT and edge devices. We mainly focus on this part of the continuum. Of course, cloud is there to support the operations, but the notion is through this mechanism to enable IoT edge devices that operate in a location to dynamically and trustworthy execute workloads in all parts of the continuum. All the formations of associations and all the orchestration decisions are based on policies, and the objective is to better serve the applications. These associations, actually each association forms a secure and virtual execution environments, and all this together they work and form the control and the management plane of an association-based continuum. Moreover, as a project, we build the appropriate mechanisms and empower these associations to support the autonomous and I-system operation of the continuum, and also we focus with the development of novel algorithms to ensure and to balance the compute and data both locally within associations and across the federated associations. In the figure, this is not the architecture. I tried not, I selected not to be too technical. It's the high level, let's say, very high level overview of EMPYREAN ecosystem and the various actors that can interact with the platform. This platform, just briefly, provides decentralized security and privacy mechanism. We support secure and efficient distributed edge storage. We have efficient source code-defined IoT edge interconnection. And we provide mechanisms for efficient data processing of ML workloads, cognitive operation, energy-aware orchestration, and also we support both the application development and the deployment phases with appropriate developments. We have 3 use cases that we use, and currently we use them. We start importing them out the developments. One is for advanced manufacture, one is smart agriculture, and one is smart campus. Sorry, I tend to speak quickly. I hope not to be too quick. I have the time in mind, sorry. I will try to... So just briefly, I will present some key results of our project and some expected key areas that we hope at the end our successful platform will cover. We cover 4 main domains that are necessary to have this to support the continuum and also the support the association-based operation of the continuum. We have developments related to security and privacy with advanced cyber threat intelligence mechanisms and distributed and trust management verification. We have support the cognitive operations with algorithms and mechanisms. We have several developments about the data storage, processing and IoT edge interconnections. and we have also support, as I said, the enable application development and deployment phases. At the end, as a project, what we aim to achieve with our successful project, we hope that the EMPYREAN platform will promote European leadership in secure, federated, and transparent data ecosystems. Our main focus is also in the vision and how it's written. Our proposal is to make more usage of IoT and edge, make this, let's say, as first citizens, and have more AI at the edge. The notion and of the associations that is we cover encourage new cooperation business models, and also we promote interoperability and portability as all the software components that we develop in open source, also the platform, and we have also developments that are, we have also development in the community, we have developments. Now, we have, as I said, we're in the beginning, the first 18 months, it was very interesting for us. We was also a consortium with some diverse consortium with new partners. The first thing, let's say, some of the things. First of all, it was very interesting for us to see how the various feedback that we received from the community and the various views of the actors, what is important about the associations. To build a continuum, it's complex, but two important things help us is the modular design, and we carefully abstract the heterogeneity. Of course, that federation autonomy can coexist with the right mix of technologies, and we hope to have more specific results on this at the end. Data and security and foundation in this at the end we do it for the data and security, for example, data interoperability, privacy, preserving credentials, and trust. When we onboard these devices on the associations is very important, and of course it was very useful for us that we have a diverse consortium, but also in the various venues that we present or initiatives would participate, the opinions and the feedback we give from various experts. Now, the way forward, it's, let's say, we can categorize in two things. One is what we want to achieve at the end of the project, which is to have the demonstrations. We want to establish this, to provide the mechanism to establish these associations. We try to maximize the deliverable of components in standardized ways to be reusable after the project and also open source. We also try to align with EU initiatives, and we participate. And such quickly, let's say, if we say after the EMPYREAN, some things that you can follow. Of course, this concept, which is actually a way, it's a proposal as a way to implement the federation. It's not the only way, but it can be more autonomous. We can have, so we can have more results to open source and generally participate in initiatives such this or others to save the future. Sorry. At the climax.
That is fantastic. So. Yes. Aristotelis, thank you very much. You stayed perfectly in time. Great round of applause for Aristotelis. Thanks so much. I would call to the stage Selma Azayas, please. The floor is yours for the COGNIFOG project. So okay. You can go to the next slide. It should be directly.
Okay.
Yes, there you go. Welcome. Thank you.
Hello, everybody. So I'm Selma Azayas from CEA List, and I'm coordinating the COGNIFOG project, which started 3 years ago. We are at the end of the project now, and briefly, COGNIFOG, we are 12 partners in COGNIFOG project. 3 RTUs and academia, CA, I2CAT, and LMS from Greece. And 4 large companies, there is TaRDIS, Netcompany, Siemens, and Atos, Eviden now. 4 SMEs and 1 association. So for the 4 SMEs are CANTU, which are responsible of building the interoperability layer, and also we have Netcompany, EBOS from Cyprus, and TMA, which is a telemedicine company from Greece. UTA is an association from Switzerland, and they help us on disseminating the project result and also to set up our pilots. So the main objective of COGNIFOG is to build a framework allowing to build a continuum from IoT toward edge layer and cloud layer in a flexible way according to the application needs. And of course, this framework should provide security orchestration capabilities and real-time scalable monitoring, as well as AI-based analytical services. So we can say that our main goal was to cover the whole chain from the cloud toward the IoT, and also to empower the fog with advanced load balancing and energy management capability. We validated also we are validating now the framework on 3 different use cases. So this is the main our global architecture of the COGNIFOG framework. So we, as you are seeing, we are covering the whole value chain, and we provide different tools to model the application and to model also the continuum with the IoT devices capabilities, as well as the edge and capabilities. And we have different tools in the runtime stage that offer security capabilities and also AI capabilities to and as well as observability, because we need to collect different data in the infrastructure layer as well as in the application layer. And for the governance layer, we have different tools also with the orchestration and smart allocation. Okay, as I said, we are validating this framework in 3 different use cases related to critical collaboration mission provided by Thales. The idea is to detect flood and to orchestrate the rescue mission. And also we have a use case about e-health in, let's say disconnected area, I mean big construction area, etc., where we don't have, sometimes we don't have Wi-Fi connection, and etc., and the goal is to monitor the health of workers, and also in smart manufacturing by connecting different robots. So what are the lessons learned from this project? That we had very good collaboration between the partners, because when we started the project, we had different views and also different expertise within edge cloud continuum. Some companies are just beginning this activities, so they lack a lot of expertise, and we had very strong collaboration. the cognitivity of the continuum is really relying on the observability and the monitoring capabilities that will be dispatched along the continuum. And also we don't really need AI everywhere because AI is very consuming. So we have to choose where we can put AI and which is the more efficient way to collect and apply the artificial intelligence to help on orchestration. So the way forward, we have now this developed framework, which it will be good to go forward and to have another maybe project to validate the concepts we have built in COGNIFOG, and we identified some interesting calls within the work package work program 2026-2027. Yeah.
Fantastic, Selma. Thank you very much. Applause for Selma, please. Thanks. And next up, we have Philippe Massonnet, representing SovereignEdge.COGNIT. The floor is yours.
Okay, thank you.
Thank you.
So I'm going to briefly talk to you about SovereignEdge.COGNIT. So it's a Horizon Europe project from the call data 0102. It's coordinated by Open Nebula. We have a roll-up right outside if you're interested in getting a bit more information. So the main problem that COGNIT is tackling is, so you have to think of the application developer. So pretend you're the application developer and you want to develop an edge application, and you have to deal with the cloud, maybe some intermediate cloud platform, the edge platform. You have to deal with authentication, credentials, the different APIs, different ways of interacting with these different systems. And so this is all very complex for the application developer that just wants to develop an application for the edge. Okay? So what COGNIT proposes is the concept of function as a service, okay, to simplify the life of the application, the edge application developer. So in this model, COGNIT provides interfaces that allow edge developers to offload functions. So it's very simple. Okay? And this is what you see here. You know, on the left part, you have the edge IoT device, and then you have all the infrastructure, you know, from low latency edge platforms to public clouds and private clouds. And yeah, and so the idea is that you give your function, instead of you deploying it, you give your function to COGNIT, and COGNIT will help you place the function that meet your requirements. So in terms of essentially latency and energy consumption. So this, you know, the results, okay, so we have key components from COGNIT. And so on the left side here, you have the device client. So this is where the application developer writes code. And he's going to essentially deal with two interfaces. The first one in orange there is the COGNIT front end. So that's where he provides his requirements about resources and things like that. And then there's some internal components that he doesn't see, the Cloud Edge Manager and the AI-enabled orchestrator that basically takes the placement decision, the plan, and then the Cloud Edge Manager will prepare the execution environment on the selected edge platform. So this is done internally, and the edge developer doesn't see this. And then once he knows on which platform he needs to execute his function, That's the second orange box there that's called the edge cluster front end. So that's where he requests the execution of his function. Okay. Yeah, and there are also there's some support for data as a service, so that you can save state information in this data as a service that's provided. Lessons learned from the case studies. So we had 4 case studies. One was a smart cities case study, where the objective was to optimize performance of public transportation in the city, increase responsiveness of emergency services, keep data and applications within the city. And there, what was very useful there is the low latency. So the kind of scenarios they had was, you have an emergency vehicle, ambulance, for example, traveling in the city, so you want to change the lights so that it can pass through. So you need very low latency to do this. And the fact that you had an edge cluster close by provides this low latency. So that was very useful there. In the energy and wildfire detection, so they both wanted to, so in the energy one, use smart electricity meters to optimize green local energy usage in household. So what they were doing is offloading the AI optimization function to the edge cluster. And same thing in the wildfire detection, where you have a lot of devices, but that have very few resources to detect fires. The idea was to offload the functions to the edge cluster. And this worked very well, and also the ability to scale these functions. So if at some point you need to execute a lot of functions because there is a fire, the scalability provided by COGNIT and the edge clusters was very useful. And I'll say a bit more about the 4th case study, because it's the one I know better, a cybersecurity case study. So there the question was, well, you have function as a service at the edge. How can you use this to do continuous security monitoring? Okay. So what we were doing was anomaly detection on moving vehicles. So we had these little rovers, okay, but it could be a drone or a real car or whatever. And so the way we had to design the anomaly detection for it to work as a function, so we couldn't install an existing package, in a virtual machine. We just could not do that. So basically, we defined 3 different functions. One that detected operating system level anomalies, a second that detected location anomalies, so attacks on the location of the vehicle, and a third that was an LLM to try to filter out the false positives generated by the anomaly detection. Okay, and so this is the way we had to design the security functions to fit the function paradigm. And basically, every time there was new data about location or an operating system level data, it would trigger execution of the anomaly detection. So that's how it was continuous. So we didn't have something running all the time, but every time there was new data, it triggered the execution of a function. Way forward, so in terms of applied research, so in COGNIT we had one orchestrator, but in reality, you need a meta orchestrator that would deal with multiple orchestrators, so we did not experiment with that. So that's one thing that could be done in the future. Function as a service at the edge, well, is this the suitable model for edge application developers? Is it too simple? So in COGNIT, we just had one function. Do we need function composition, so richer operations on functions? Do we need that? How can you better support AI at the edge? So with anomaly detection, we discovered that the default models were not detecting all the attacks we were throwing, so you need to train. So you need to train the anomaly detection, so we need mechanisms for that. And also the impact of data as a service latency on edge latency. So if you're storing data and it takes a lot of time to get the data to execute the function, well, you're going to miss your latency requirements on the function execution. So quickly, and in terms of exploitation, just to finish, so maybe we'll find some of these components in future releases of OpenEBLA, okay? If we had that, then case study partners could then operationalize their case studies into real deployments. And Nexus members and IPCEI members might want to experiment with the COGNIT framework to give us feedback, is function as a service the right model for edge application developers? Thank you.
Fantastic. Thank you very much, Philippe. Very, very kind and very interesting presentation. So by all means, I think there are really a lot of opportunities to keep in touch here. Sorry, I think I made a mistake here. Okay, so now next up we have Felix Stein and Mira Kaidin. Felix is going to present from the DCEI project. The floor is yours. Thank you very much.
Thank you very much. Yeah. Good afternoon, ladies and gentlemen. My name is Felix Stein. I want to tell you a bit about our European Horizon European project, which is called DCEI-CIS, together with my colleague today here, Miraj Aydin. What is DCEI-CIS? It's a device edge cloud intelligent collaboration framework, which is currently being developed by the University of Göttingen, the GWG, as well as 10 other partners. And as Francesco said, we prepared a few slides, talk about what the project actually is, the objectives, and way forward. Starting with the key objectives, and just to give you an overview of what DCEI actually is. As I said, it's an open source cloud management framework, and it enables the user to deploy jobs across the heterogeneous compute continuum. So if you want to deploy a job to the edge or cloud or HPC, DCEI is making that possible. Apologies. We're using a scheduler that has been built and trained by us to find the optimal job placement across the compute continuum. We also offer advanced APIs for users to interact with the system, the different platforms, the resources, as well as the machine learning models we offer. Besides that, we also developed a digital twin, which is sort of representing digitally in memory the cluster layout, where we also run different operations like anomaly detection, energy efficiency, etc., which is way faster than actually pulling and processing the information from the cluster all over again. And then besides that, also the framework itself, GDPR compliant, very important to us, so that user and admins alike can use the platform safely and securely. Our key exploitable results, well, first and foremost, the framework itself, which offers, as I said, a job deployment across a hybrid compute continuum, including HPC, cloud, and edge clusters. We also developed a virtual training environment which simulates infrastructure and application scenarios to optimally train the AI models. Whether you want to improve our existing models or put new models into the data pipeline. Speaking of AI models, we also developed, as I said, the AI scheduler, which finds the optimal job placement across the compute continuum. Also the dynamic digital twin, which constantly stores the snapshot of the cluster, as well as storage and networking resources with real-time monitoring. And then, of course, another big part of the key exploitable results from our side are the datasets, which we created in order to successfully train the AI models. Of course, the target groups, we think the DCEI framework can make an impact or even benefit are data centers, as well as scientific communities, developers, startups or even enterprise companies. Of course, we also had challenges while developing the platform. First and foremost, the biggest challenge for us was finding the right amount of input for actually training the AI scheduler. We had to find develop many ways to actually gather or create our own data sets for the training process. And then besides that, job scheduling on HPC clusters via the framework itself. Not only is the compute continuum itself very heterogeneous, also the HPC landscape in itself is also a very heterogeneous compute continuum, if you will, and there's just no one size fits all. So this was also a big obstacle for us. Solutions we came up with is, for the training data situation, we collected time series data from our Prometheus cluster, as well as open source data sets that have been provided by our partners. And for the HPC situation, we utilized Slurm and its APIs to communicate with HPC clusters. Works quite nicely. And the outcome of this is that now we have good working models when it comes to the scheduling process, as well as we now have more control over deploying HPC jobs and doing the accounting compared to other open source alternatives out there. Of course, last but not least, our way forward. Things we are still developing or we still want to improve while the project runs. First and foremost, our digital twin. Here, we want to enhance the digital twin itself to support more complex simulations. As I said, we also implemented anomaly detection, energy efficiency, but of course, these models can be made way more efficient and faster. Then one key component, of course, is the AI scheduler itself. By extending AI scheduling capabilities with new algorithms or like real-time optimization and predictive maintenance, as well as just offering new input features the AI scheduler can use to determine the optimal job placement. And then also workflows. We are covering a wide range of different workflow management tools users can use to upload or submit jobs to the platform itself. So users are not bound to a specific system or file or even data format. Of course, we want to extend the edge cases there as well, or cover more edge cases and extend the capabilities. And then last but not least, the platform itself, where we want to support different orchestrators. Right now we are working with Kubernetes, and of course there are other orchestrators out there when it comes to cloud and edge deployment. Yeah, thank you so much.
So, fantastic, thank you very much, Felix. Thanks, this was really, really interesting. So, next I would call to the stage Tarek El Saleh to represent the SEDIMARK project. So, Tarek, no worries about that. Thanks. The floor is all yours. Thank you.
Hi, good afternoon, everyone. My name is Tarek El Saleh from the University of Surrey, and I'm presenting the EU project SEDIMARK, which has recently finished last month. So what is SEDIMARK in a sentence? So basically, it's a decentralized data and AI marketplace. So essentially, it is an open source framework for data spaces. So in terms of the objectives of the project, so essentially the main objective is to develop a secure, decentralized data marketplace, which involves creating a privacy-preserving decentralized framework, and using as a core component the distributed ledger technology, DLT, and self-sovereign identity for decentralized identity management and integrity or transparent integrity verification. So essentially, the aim is to avoid centralized control, to ensure data sovereignty and trust among participants. We also obviously want to support the EU common data spaces, which essentially to align with the vision for interoperable cross-sectoral data spaces, to provide tools for the data lifecycle management, which includes tasks such as data cleaning, curation, and federated learning. Also to enable intelligent asset generation compliance, so to support heterogeneous, high-quality certified data asset sharing across domains, facilitate AI-based enrichment, semantic annotation, and on-demand model training, to implement mechanisms for data validation and standard compliance. We also want to enhance data discoverability and exchange, so improve how data is discovered through decentralized fair enabled mechanisms, advance sustainability and and efficiency by aim of reducing energy consumption within data processing and AI workflows, and to support green digital transformation through optimized data and model workflow handling, to promote innovation and economic growth, so enable data monetization of the data sets and AI models that are generated through the marketplace, or for the marketplace, and introduce new business models. So in terms of domains of intervention, I guess in the context of kind of EU terminology, so in terms of like key digital technologies, we kind of focus on secure digital infrastructure, data sovereignty, security, and interoperability. In terms of AI and robotics, focus on distributed AI and data processing, and scalable and energy efficient secure platforms. Within kind of next generation internet theme, focus on decentralization, user control, and privacy. And also in terms of world-leading data and computing technologies, we focus on data lifecycle management, distributed computing, and collaborative data ecosystems. So essentially, probably this is just the only diagram I have here for the presentation, and just to kind of follow the format. So essentially, the SEDIMARK framework just comprises of essentially what is called a toolbox that we provide to what is called a participant in the marketplace. So the participant can be either a marketplace operator, a data provider, or asset provider, or consumer. And essentially, they will use a toolbox for generating the assets, so like a mini factory, and then also to be able to advertise those assets in the marketplace through creating what is called offerings and putting them into what is called a catalog. And all this is done and registered through the DLT. So the DLT's role is to kind of keep track of what's going on in the marketplace in terms of user registration, asset or offering registrations, or transactions that are done between consumer and providers. So essentially, the key exploitable results are for the project that we have an orchestration framework in the context of data or data sets and data kind of assets for asset generation and also AI model generation. And we also have what is called the orchestrator, like we've been hearing in previous presentations, but in the context of providing orchestration for workflows that handle data quality, interoperability handling, AI model training, inference, and optimization. And also we have automated pipeline generation through which is LLM-based, using the common workflow language, which is a standard. And also providing federated learning frameworks where basically participants can collaborate with other participants within the marketplace for federated learning purposes to generate AI models that will use for inferencing for particular use cases. We also developed a distributed data brokerage mechanism and cataloging through the Stelio and NGSILD broker, which is one of the brokers used within the FireWare framework, and also our distributed cataloging solution, Catena, which is RDF-based, used for providing discoverability for the assets in a decentralized manner. Obviously, we also got the DLT-based trust framework based on the IOTA ledger, which provides what is called the Tangle and the smart contract chain. We also make use of the Eclipse data space connector, which we've built upon to actually interact with the DLT. And also we have a dedicated marketplace UI, which provides service task for onboarding participants, publishing assets, and discovery of assets with a recommendation system. In terms of impact, I'll probably skip that. Just to go through lessons learned. So in terms of challenges, obviously, one of the things that we wanted to do is obviously be able to handle workflows for data, asset, and IA model generation in a generic manner, which is obviously not an easy task. Obviously, you're dealing with data sets that will have different properties and different types of primitives. So you could be dealing with strings or dealing with integers or floats and so on. So all that, handling that in a generic manner is not an easy task. Also, when you're dealing with AI workflow processes, obviously, especially in deep learning context, you need to really kind of separate the metadata from the data, since usually these deep learning methods, they only basically go on the data. So even though interoperability on one side is very important, you need to be able to extract the data from there, feed it into these workflows, and then reconstruct it back into an interoperable format for exchange, which is also not an easy task when working with different data sets from different use cases. Standards for interoperability, obviously, there's well-known ones like RDF and NGSILD for information exchange. What do we use? So essentially for data discoverability, we basically see that RDF is obviously a better option in the sense that it's able to link with other data sets. NGSILD is a more palatable format for data sets as well, providing more data structures to support big data. Also, dynamicity in decentralized frameworks, again, is an issue. You have participants joining, potentially joining and leaving. How do you handle that? And how do you maintain business continuity, especially in a decentralized manner when you have basically, if you have a decentralized catalog, that decentralized catalog will rely on other participants. If they go, what would happen? You'd have to obviously re-establish the catalog and act obviously according to that. Obviously, in terms of conformance, barriers to entry, obviously, description generation is not a trivial thing when you're creating metadata. And basically, we also introduced semi-automated service for asset and offering description generation, which is also edge-based. Way forward, basically, edge optimization for a Gen AI-based tool is not, obviously not a trivial thing, which also is something that needs to be improved. We have been going towards that, but there's still a lot to do in that area to truly be able to have Gen AI on the edge, which is kind of reliable. Multimodal synthetic data generation is also, for digital twin supplementation, is important, or beyond the real world data. So to also, relying on real world data is not enough. Governance and compliance frameworks need to go beyond interoperability and privacy, obviously to cater to regulation as well. But how to do that in a, within a technology framework, which is not a trivial matter. Incorporating DLT-enabled provenance mechanisms and streamlined verification for trust building, so tracking data from the source, the final product, and beyond exchange. And also engaging commercial stakeholders for co-creation for productization and policy definitions for marketplace asset exchange, and not to just rely on basically engineers like us to define these, and also to provide training support with respect to compliance and regulations. Thank you very much.
Fantastic. Thank you very much, Tarek. Thank you for the presentation. So next up we have Hui Song, who is going to represent the Intent project. The floor is yours. Thank you.
Yes, so coming about our project Intent. I've been listening these 2 days about the exciting projects like IPCEI, where we're building Europe's infrastructure with data centers federated together and also extending to edge devices. The natural question comes with this is how difficult it would be to manage such complex infrastructure. And this is a common question for operating any complex systems. And in the domain of networking, there's a new concept popping up, intent-based networking. So the idea is that they only expose to the end users or application developers the interface for them to describe what they want to achieve, the intent, and then leave the management to the what they call the intent manager, which is essentially the smart management system. And we want to extend this from networking to the whole computing continuum for intent-based management. The research challenges behind this is if you really want some system that understands the human intents and do the system management according to that, what you need is something smart enough, kind of like with the human-like intelligence. And we break this down into 3 essential properties. They need to first be able to adapt like a human. They need to understand the system, learn from the system, and decide what to do with it. And they need to think like a human in a more strategic way. If you have different systems or different aspects or different managers, how you can collaborate or coordinate them. And finally, they need to understand what the humans are talking about, understand the intent inside it, and also try to explain to the human why they did or they make certain decisions. With this, we are developing in total 10 different intent managers. They're essentially the prototypes of doing intent-based management in 3 different layers. The yellow one in the last bottom layer are the resource management based on intent. So here we look at the management of computational resources. That's basically orchestration, the storage management, and network management. I won't go through all the tools, but I'd just like to use an example for the orchestration. If you do orchestration using Kubernetes, essentially you only want to tell that I have this container, I want it to run somewhere, and I have some expected performance. But we have a partner, Intel, developing the intent-based manager, extending Kubernetes. They want to expose some advanced configuration points of their chips. There are so many things that you can configure, and if you configure it properly, it will really make a difference about how the workload perform on their chips. But the thing that they cannot open the complete manual about how to do these configurations. First, they consider this first as too complicated, and second, some of them, they don't really want to make it public. And what they want to achieve is that they open the intent-based interface. So you describe what kind of latency you want, what kind of energy consumption you need, and leave the management to the experts. That's basically developed by the Intel engineers and researchers themselves. And the next level, in the blue level, when we have these different resource managers, how we can coordinate them. So again, from an intent-based perspective, you receive the intent as the global perspective, and then you let your coordinator to monitor how the different resource managers react to these intents and try to coordinate their numbers in a way that it finally fit the global perspective, global expectation. And finally, the green ones are about how to understand what humans really talk about. Here we have the key exploitation results on the intent, conventional intent interface. That's essentially a chatbot, but understanding the network management intents. And we have the translators, which can translate the natural language intent into the system-specific intent that these low-level management tools can understand. Key lessons learned is that what we really want to develop here are the agents. So that also means we want to understand this system and experiment system in an agentic way. So we need an agent that can control the system automatically. They can observe what's happening in the system and control them to fulfill the intent provided by the stakeholders. And these decisions has to be made based on their knowledge about the system. This knowledge can be provided by experts from externally, or it can be the knowledge that the agent learned themselves and eventually embedded into their AI models. And very quickly about way forward. So eventually we want to use this agent to support the infrastructure for the future AI workload. And we also have the expectation that a lot of these AI workload will be agentic themselves. So that brings the interesting question that can the agent themselves provide the intents instead of only rely on stakeholders? Then we will have a system that tells the infrastructure what they want to do, and we will have the infrastructure agents and application agents work together to achieve the real smart system and infrastructure management. And beyond that, we really want to get in touch with people from IPCEI, from ORAS, and from OpenNebula to see how these prototypes can actually be applied or at least tested in your stacks. We don't want to replace your stack, but would like to see if this might be able to provide alternative way for your application developers to use the resource in the most efficient and easy way. Thanks a lot.
Fantastic. Thank you. Thank you. Thank you very much. I don't know. Can you hear? I think the mic is okay. Thank you very much, Hui, and loved also the call to action in your last bit. Thanks so much. And next up, we have Carla Ferreira, who is going to represent the TaRDIS project. Carla, the floor is yours.
Hi. So I'm here to present the TaRDIS project. So this project, I'll go ahead for the next slide. This project is focused on making the life easier for developers of Swarm applications. So let me start by defining what are Swarm applications. So these applications are decentralized, where you have devices connecting and disconnecting. You don't have a central authority deciding what happens. And so these applications are very complex to develop, and they require expert teams for that. And we are tackling this we are focused on 4 pillars here. The first is the programming abstractions. The programming abstractions, I'm short, that's all. So we are focusing on the programming abstractions, and we propose an event-based programming model where you decompose your system in components. And this programming model hides underneath all the nitty-gritty that is needed to build these applications. So the idea is that you provide APIs to deal with the difficult tasks. For instance, distribution, membership, because you have these connecting and disconnecting devices, we need complex, protocols to deal with this. And so we have these 3 APIs dealing with distribution, dealing with the data management, and also providing decentralized algorithms for AI and machine learning. And this helps the developers. Another aspect that is crucial in this project is the verification, or I would say is our strong point. So we try to provide guarantees that the applications satisfy certain properties. So obviously you're not building here applications that are correct by construction, because that's very difficult in real systems, but we are checking some guarantees. You also have the runtime, so it's not just the development, we also support the part of the deployment and then the operation of these applications. I'm skipping loads of things, but that's general idea. What are our key exploitable results? So we have this Babel framework. So this is the part that deals with the communication membership. And this is open middleware, and it's able to deal with devices, so very simple devices to if you have a drone or different types of devices. We have a middleware, Actix middleware, so this is focused on industry shop floor industrial applications. So, and this is already been installed, so the pilot is being used in a factory, in a real factory. So this is quite promising. And as I said, here we do also some verification of the definition of these workflows that are very complex in factories. We also have developed this with Telefonica, some privacy-preserving decentralized training. So the idea here is that you don't move your data, to then build, to train and do the learning, but you keep the data locally and you do what it's very well known, the federated learning. So, but you keep your data locally and private. Well, that's really important in the case of Telefonica. We also have a decentralized data management framework, and so this deals with geo-replicating data in multiple locations. And here we also have some adapters for legacy backends that already exist. So it's not just our solutions, we are able to interact with existing solutions. What worked in the use cases? So I don't have what didn't work, so I'll start with the negative. One of the things that is proving quite difficult in TaRDIS is we have loads, so the toolkit has loads of small verification tools, and connecting all these is not easy. We have a solution that I'll talk later, but what worked? Well, in the use cases, I think we were able to have some impact. For instance, in the case of the satellite swarms, it's very expensive when you have satellites, the connection to the ground station. So that's very expensive in terms of fuel that it's spending. And we developed with the team from the company, GMV, we developed a distributed orbit determination that is it's more efficient. So the orbit delimitation can be done in a decentralized manner instead of going always to the ground station. I already mentioned the factory, and I also mentioned Telefonica, so where we have this differential privacy and also lightweight methods for learning. I interpret the way forward, how do you keep TaRDIS alive? So we are releasing our tools as a toolbox. So the use cases, some of the industrial partners are integrating the results in their company and using them. So that's a way to keep the project alive. We are publishing, at the end of the project, the cookbook. So it's very difficult to develop these systems, and you want to say, oh, if you want this type of swarm, follow these paths. Of course, this is focused on our approach, but still, I think it's helpful. And one of the, I think, distinguished features of the project is that we provide formal verification, of course, again, of some specific properties. And generally speaking, that's it, and this is the consortium.
Fantastic. Thank you very much, Carla, for a nice and interesting presentation. And now we have our last speaker for this session, so Bretos Moulos, representing the P2 Code project. The floor is yours. Thanks.
Thank you. Hi from my side. The project I would like to present to you is P2 Code. Actually, more or less is close to the other project that was just presented. So what we are trying to achieve, until now at least, is to find a way to orchestrate the resources from the IoT till the cloud. So we have three main pillars or key interests, let's say, of the project. The one is the resource management, where we split it into two different layers. The one that's about the resources per se, and the second one about the orchestration of the containers or the services that we have. The second one is to have a vertical, let's say, component, the security and trust layer, where we try to achieve zero trust architecture design in a way that it will be transparent for the user. And the third one, which is quite important, at least for interoperability reasons as well as for integration reasons, is the focus to the standards, to the open standards that we would like to follow up. So our key exploitable results, or what we believe we can transfer to the community, is about starting from the first pillar, which is the resource management layer, is the focus or the try to achieve 100% compatibility with the TM Forum. So we already have implemented several API calls regarding to this aspect. We also have integration of several resource orchestration tools in relation to the telemetry and the anomaly detection. So we have wrappers that are compatible with these designs. And since one of the partners is Red Hat, we have 100% compatibility with OpenShift, so in relation to Kubernetes. About the security and trust, since it's quite important for us, we also follow open standards here, and quite important thing is that we offered add-on services on top of TM Forum APIs that exist. And about the third part of the impact, two of our partners, one of which is University of Patras, is actually leading the EDGE initiative about the open slice. So all the work that have been done there, it's also contributed to the open slice initiative and the implementation that they more or less they implement. So about the lessons learned and the challenges that we had during this project, the first one, as you already mentioned, most of you, is the heterogeneity of the infrastructure. So we have different vendors, different implementations, different designs, different software implementations. So there is one more reason why to follow open standards will give us the opportunity, different players from the European, at least, community or layer to have access to these implementations. The second one, which is about the security and how we can spread it around the full implementation. Again, following the TMF forum initiative and the hardware that we actually have, one of which is the TPM, as you already know, most of you, due to Windows 11, the issue that with compatibility that exists. We try to incorporate it even to the IoT. For example, we have an implementation in Raspberry Pi implementing also TPM hardware compatibility. About the third one, which is more or less politics related, it's the policy complexity. Here the issue is that although you have designs and implementations about security, in the end you need a tailor-made implementation based on the use case that you have. So in this manner, you need something which is user-friendly oriented in order with low code or no code programming to be able to design or implement your own or custom policies. And the third one, which is the cross-border compliance, it's a thing that was also already discussed in the last presentation yesterday. The main issue in relation to the US is that we don't really have open market. We don't have a market, at least till the last decade. So what we really need to do is to access and offer our services to the full market, at least to the European Union. So ADAS was one of our priorities in order not to limit it in a specific region or a specific country, the designs that we have. Going forward now, and what we can do as a next steps, we already have motivation to follow open standards and actually contribute to the foundation of open standards initiatives. As I said before, Red Hat, University of Piraeus, UBTech are some of the companies or organizations that already contributed to this. So TM Forum API is something that we will also contribute, as well as OpenSlice, which is the one which will give us the opportunity to provide interoperability between telecom operators, which more or less is an area where is quite fragmented. As a future directions that we have, certainly AI will be one of the things that we would like to consider, as well as the opportunities that raise due to 6G networks. Quantum is the next bubble or the next thing that we will going to see in the next in the future years. So for sure, we open the door to this area in case we need more to focus in relation more or less about the security. So that's it. Thank you all.
Thank you. Thank you very much, Bretos. Okay, so thanks to all of the speakers. I mean, we are absolutely perfectly on time, and I'm really sorry for being really a kind of an annoying watchdog on this. So as we have just a few minutes, I'll check the time because otherwise then Daniel is going to be unhappy with me. So we have 5 minutes. First of all, I was wondering if there are any questions from the audience about these presentations that we just listened to. Okay, then I will again bother the speakers with a question based on what they listened to in the other presentations from the other participants. So we had a structure in the presentations, right? So we had these 4 key higher points. Is there something in particular which you found interesting in the presentation of some of the other colleagues that you thought, okay, this is something that can be useful for our project, for our work, either something from the technology perspective or something from the market perspective, the data perspective, whatever came to your mind. I don't know if you have, no, okay. I don't know if somebody wants to think about this, try to share their experience, their feelings on that.
Okay, thank you. So, I mean, with regards to, with regards to SEDIMARK, we are essentially a solution that we're focused on the kind of software level where we provide this framework for deployment, primarily or targeting an edge-based kind of deployment. I think one of the things, obviously, with regards to the projects presented, I think one of the things that we seem to always struggle with is in terms of compute provision, and I think that's one of the challenges that we have. I mean, especially in the sense where we want to actually deploy a solution that's externally accessible and so on. Obviously, within our organizations, we do have our kind of means of kind of limited deployment. So we might have like a server here and a server there. We might have a set of servers where we can probably install like an open source kind of cloud framework. And I think basically, I think one of the things that I kind of see is that we do need to have some kind of, I would say, system that we can use as kind of like a playground that simulates kind of like a real world deployment, and that we can actually have hosted kind of as a system, running at least within that kind of like deployment. So it's really as I've kind of seen from COGNIFOG. I guess do you actually go on? I think where's she left, is she? She left. Okay, that's fine. So I guess that was basically mainly the main kind of, I would say, thing that we're probably missing is to have that kind of playground to able to kind of deploy our solution, rather than every kind of partner, making use of their resources. But the thing is, when you come at the end of the project, those resources might not be available anymore. So it's really that kind of what we're missing.
No, absolutely, Tarek. I think it's an excellent point, and actually, really, it's something to think about, and maybe to find a way to cooperate further also with the other research and innovation actions, and maybe also through the EU Cloud Edge IoT platform. When we have the calls and everything, it could be a place to discuss that as well. So thank you again very much to all the speakers and the audience. I think we have to cut the session, right, Daniela? Do we have time for one question?
Really short one.
Really short question.
The question can be short. Maybe the answer is not.
No, the answer should be short too.
The answer is not short. No, it was a kind of, let's say, provocative question for all the speakers, because we have seen many interesting pieces of technologies, no, in these presentations. Some of them are really potentially exciting for the future. So how far are we from a situation where we describe what we want to the network, to the cloud edge continuum, and some kind of intelligent agents, they provide the function, and we don't have to worry about security, software development, and so on.
Who will volunteer on this question? I think it touches upon some of the presentations. Any volunteer?
So regarding the part of programming where most people, or there's loads of promises from LLMs, I think the quality of the code produced is not great. So I would say okay, maybe I can accept that. But at the moment the results are not that. The code is very difficult to debug. So it improves the productivity, but building the code from scratch, it's not that easy. But maybe that's the training. I'm not too confident on that.
Thank you very much. I believe we will have a coffee farewell at the end to tackle on this, on a debate or a session, because it is indeed quite a provocative question. Thank you. And would you like to say some more words?
Thank you. Thank you very much for joining the session and for participating. Thanks.